In this video, I am going to walk you through the solution to 2004 AB3 free response question. The question says, a particle moves along the y-axis so that its velocity v at time t is greater than 0 is given by v of t equals 1 minus inverse tangent of e to the t. And then it says at time t equals 0, the particle is at y equals negative 1, which is our initial condition, and we'll talk about that at the end. Letter A says find the acceleration of the particle at time t equals 2. Well, I know that I have to take the derivative of velocity to get acceleration. But this is actually a calculator question, so I'm going to let the calculator do my work for me. All I'm going to write down is that I know velocity, the derivative of velocity equals acceleration. And I want to evaluate that when t equals 2. So I'm going to plug in 2 for the derivative of velocity, and that will give me what acceleration is when time is 2. So we're going to use our calculators, and we're going to use the nderiv function, which is under the math menu. So you press the math button and you choose option number 8, and it will be nderiv. And you enter your function first. So you're going to type in your function. And we actually want to just use x because it's easier. Then you do a comma and you tell the calculator I want to take the derivative with respect to x. And then I want to plug in 2. So you type all of that in, and what you will get is negative 0.133. And that is my acceleration at 2. Okay, for letter B, it says, is the speed of the particle increasing or decreasing at time t equals 2? So I know speed is directly related to velocity. It's just the absolute value. And the way you tell if the particle is speeding up or slowing down is if the velocity and the acceleration have the same sign or different signs. So in the previous example, I already figured out that acceleration at 2 was a negative number, negative 0.133. So now all I need to figure out is what is the sign of velocity. So I am just going to plug in 2 to the velocity equation and just type it in my calculator and see what the sign is. And I get negative 0.436. So since both of these are negative numbers, then I'm going to say the particle is speeding up because it has the same sign. And I need to write a reason for my answer. So I'm going to say the particle is, well, let's make it more. The speed of the particle is increasing because A of 2 is negative and V of 2 is negative. So that tells me that they both have the same sign. So I understand that if they have the same sign, then the particle is speeding up. And that shows the AP test takers that I know that. Okay, letter C says find the time t greater than 0 at which the particle reaches its highest point. So I know highest point, it's talking about maximum. I want to know when is its maximum height. So the way you find a maximum is by taking the derivative. And we're talking about its highest point, so that's its position. So I need to take the derivative of position, which I already have, and that is velocity. So I'm going to go ahead and write my equation down one more time. Okay, and once I take the derivative, I need to see where this is 0. So I am going to set it equal to 0 and get my critical points and put them on my sign line and see where I have a maximum. So I'm going to solve this by adding tangent, the inverse tangent, to the other side. And now I want to get rid of tangent, so the inverse tangent. So I know tangent and inverse tangent are opposites. So I'm just going to take the tangent of both sides. So now these two will cross out, and I'm left with e to the t equals tangent of 1. Now I need to somehow undo the e. So the opposite of e is natural log. So I'm going to take the natural log of both sides. So over here I'll just get t, and on the right I have natural log of tangent of 1. And I will just type that into my calculator, and I get 0.443. So now I need to test it out on my sine line. And I know that time is not negative, so we're going to start at 0, and we're going to put on 0.443. And the good part about this question is that it is a calculator question, so I can actually graph this to see where this function is positive or negative, or I could plug in numbers to my calculator. Either way works. Okay, so I've added in a picture of my calculator here, and you can see that I actually use the calculator to calculate a 0, which I could have done instead of working it out by hand. As you can see there, I got the same exact answer. But I'm going to use this to actually evaluate, and I see that before the 0 that my function, my velocity is positive, and after the 0 it's negative. So I'm going to fill that in on my sine line. So going from positive to negative gives me a maximum. So the time 0.443 is a shows that the function is a maximum there. Okay, so I'm going to write my final justification at time t equals 0.443, the particle is at its maximum height. And how do I know that? Because the velocity changes sign. So you could write, because the velocity goes from positive to negative, I'm going to write it a little more mathy way because that's the way they wrote it on the solution guide. So I know that velocity is greater than 0 when t is in between 0 and 0.443. And so that means it's positive. Velocity is negative when t is bigger than 0.443. So that shows them that I know that it's changing from positive to negative, and therefore it's a maximum. Okay, the last question is a little bit tricky because you have to really think about what it's asking you. It says find the position of the particle at time t equals 2. Is the particle moving towards the origin or away from the origin at time t equal 2, and justify your answer. So I'm going to tackle the first part first. I want to know what the position is at time t equal 2. So that I've got the velocity equation and I want position, so I know I'm going to have to integrate. But at the beginning of the question, it told me when time was 0, initially, the particle is already at y equals -1. So we're not starting at 0, we're starting at -1. So if I'm going to evaluate what the position is at 2, I need to take into account what the position was originally, and then I'm going to integrate the velocity equation, because that's going to give me my position from 0 to 2. So what that's going to do is that's going to say, okay, this is where I started, and this is how far I moved from 0 to 2, and then it's going to add those together to tell me what the real position is at the new time. So it told me at y0, when time is 0, that y is -1. And then the second part, I'm going to type into my calculator. So I'm going to type in FNINT, which is in the math menu, and number 9, and then my velocity equation, which is 1 minus inverse tangent of e to the t. Okay, again, We're going to use x's in our calculator. Okay, and then you do a comma, and you tell it you want to integrate with respect to x from 0 to 2. So this is going to give me how far my particle has moved from 0 to 2, and when I add in with the true sign, positive or negative, and then when I add that to the initial position, I can figure out where this is right now. So when I type all of that in, I get negative 0.3606. Okay, so we'll round that to 1. And when I add that together, I will get negative 1.361. And that is the position of y at 2. Okay, so the last part of the question says, is the particle moving towards the origin or away from the origin, and justify your answer. And so the way I would think about it, I know when it starts out, it's at negative 1. And now here at 2, it's at negative 1.361. Well, that's more negative than the negative 1, so it's moving to the left. So that tells me that it's actually moving away from the origin. So I need to write a justification. So I'm going to say the particle is moving away from the origin because my initial position is actually bigger than my new position, and they're both negative. So if y2 is negative and y0 is negative, then when y0 is bigger than y2, that means it's moving more to the left. Okay?